My name's Jeremy. It's just a thrill to have this day for the collectors, for the enthusiasts, and have it open to the public. So, of course, thank you from me to Radford as well for hosting the space. I have a good sense of humour, and I've found that life is for living. One can't take this stuff too seriously, so I just opened the slide saying, this is my Fun with Flags presentation on capacitors. A little bit to do with restoration as well. What I've found is that there's a huge amount of information online about YouTubers restoring things, which is great, but it's not a conversation whatsoever. And so if you're trying to recap something or learn something yourself, it gets to the point where you can sort of do something in 2 hours that maybe took you 2 months if you just had the help from somebody. And it gets to come to the point where it's like, well, why wasn't I told this sooner? I don't know how to clean my boards. I don't know how to deal with capacitors. I don't know how to deal with corrosion. I'll talk you through some of that, but also talk you through about how to turn something on safely. So let's have a look. So there's words we'll be using include electrolyte, how to turn something on without blowing it up as well. I mean, we're here because we're talking about things that are 30 to 40 years old easily. It is 2024. It catches me every time how old something really is. So can we turn something on safely? Yes. And how do we do that? Some of the practical methods to restore our circuit boards as well. I'll talk through some products you can buy so we can throw some money at the problem. Now, I also just did some little fun facts. As we experiment with things in life, Goof Off is at Bunnings in the paint aisle. It is the most perfect way to clean glass, including all the shower sort of scum. I had no idea, but if you ever wanted to clean a shower in 2 seconds, Goof Off and a Mr. Clean. Exercise for the lazy. I am lazy, but I've also had a severe injury once upon a time, and I have had a wonderful recovery. Kettlebell swings. If you've got a bit of back pain, I guarantee you it is the best exercise I've ever done for the time. 2 minutes. And also vinyl records. They're noisy, they pop, they click and they squeak, but they're lovely, they're physical. You can play them, but did you know you can play them wet? Yeah, you can. Get a spray bottle and at a distance. And what does that do? All of the noise just drops right down because the surface tension on the record is nil. Your stylus glides through the water so smoothly and so beautifully that you will never hear a bit of excessive crackle again. And your records will last longer too because they're not being shredded so much by a needle going over them. So if you know, you know. I guarantee it's worth trying once. So the definition of embalmment is also something to talk about. What happens to our gear when it sits in storage? We know the Egyptians did it as an act of preservation, but our circuits, as I say, are being injected by something. It can be off-gassing, gross word. It relates to batteries. When they're in a computer case, they off-gas, they corrode the surrounding area, as does electrolyte. It seeps out from things as it sits with time, unfortunately, depending on especially the era, but it's less relevant talking about eras now considering everything's 30 and 40 years old. It goes through. And what do capacitors sit on? They sit on copper. Copper turns green and it also tracks. It's a vein. It's an intravenous injection. It just sucks it up. So the capacitors are sitting on something that is thirsty for electrolyte, which unfortunately is what is plaguing a lot of our gear. It's something so simple as even a floppy drive. Okay, let's try a floppy drive. That's not PCB fixation or green. You can see this kind of black stickiness to it. There's a furriness to what's going along down here. That's coming out of these two capacitors. It goes through the gold-plated pins and through the cable and then into your logic board. So that example is to sort of train your eye. If you can see this sticky stuff, that is leaked electrolyte that has dried out over time, and it attracts dust as well. So that is part of a problem. You'll start to feel that everything is doomed, by the way. We're not. You can save this sort of stuff. But it's in everything. This is not such a bad example, but it's hard to see straight away. Can you see the green? There is some green there. Leading up to that, there's also a bit of a break, and you can see that bit there is missing. So that green should be touching that green there. This is a power supply that sat over time, but it was also a bit of a bad design. So we'll talk about that a little bit later, but why a capacitor's dying. This can also be fixed as well, but it's just another example of basically every computer with this power supply doesn't turn on anymore. We're trying to save things from e-waste, and it can be done. But again, I'm showing you this. I want you to visually start to hone in on what am I looking for. You see these black dots? They're not supposed to be there either. The Apple PowerBook, lovely grey kind of computer that has a brick power supply. If you've ever seen a resistor, it shouldn't look like that. They're usually typically a nice kind of yellow beigey colour with colour bands on them. Can you see how it's actually turned translucent? So this is from leaked electrolyte coming through and embalming these resistors. It also starts to get a bit dodgy because you're turning something on potentially that is absolutely shorted all the way through. And if you're designing a power supply, you might put some protection in there for certain components to fail, but you haven't designed it to fail 40 years later. This is not uncommon. These are not my worst case scenario. This is stuff that people send me monthly, weekly. Again, this is an easy one to see, but these traces are missing. So therefore, this circuit is open. It's just as bad trying to get this turned on if your friend said, okay, I'll get some tin snips. Let's turn on your Panasonic 3DO, your collectible console from Japan. I'm just going to cut some components out and see if it works. It's dumb. It's dumb to try and turn something on that you don't know that you're turning on. It could be this bad. Again, this is an example of the off-gassing sort of stuff. So there was some leaked batteries around this area, and you can see on every single pin. So this is also not salvageable. Part of using our senses and using what we know about sort of corrosion, you have to also pick your battles, and there's some more examples of that. This was a board that was sent to me that somebody had cleaned with alcohol. So I've said, there might be a slide come up, alcohol is not a solvent for electrolyte. It's a universally accepted solvent. It might clean off some goo perhaps, but it doesn't clean off electrolyte. It's just like if you were to clean your toilet, you want to use some proper toilet gel stuff, you know, it cleans it properly. You can't just clean it with water or alcohol. So when you look closely in, this is what you're turning on, and this is all conductive. So I feel like we're doomed, aren't we? But that's a Macintosh board. All of those legs are suddenly joined together. The caps are leaking from the bottom as well. So if they're sitting flush onto the board and they're not vented, they're leaking on the bottom. So it's really interesting what you find when you take stuff out. This isn't this lovely gentleman Neil's, but this is a Mac Classic 2 board that was turned on from storage. So this could have been mitigated, potentially, but again, this is a power regulator, so the whole board is shorted, and it did actually spark. Okay, this kind of slide feeds into looking at, can you recap something forever, and how do I replace every capacitor? It's just not rational, is it? Is every capacitor bad? No. Can I prioritize what I need to replace? Yes. So we look at why do they fail, and that's what we replace first. So anything surface mount gets done, those little tiny silver caps. When we're looking at basically anything else, stuff in your power supplies, televisions, you look at what's been worked too hard. So you can zoom in on the board. I've got some examples. Does something look baked? That's a lovely term, baked. Nothing to do with anything illicit, but is the board baked? Heat stress, is the PCB dark in an area? Can I see a capacitor leg that's a bit shrunken or something? The outside of a capacitor has got a plastic coating on it, and it will shrink back. It will retract if it's been really hot. So heat stress is a big problem. And why do the capacitors fail? Well, it's also just not forward thinking. I mean, we talked about this, other people talk to you about warranty times. These products are only supposed to last past 12 months and then that's it. We're lucky that they're sitting at 40 years time, but if you were to recap something, you would zoom in on what is sitting next to burning hot stuff. Are they resistors that are baking your capacitors? So you would zoom in on those. I mean, you might have 50 capacitors to replace. So sort of prioritizing things. The capacitors are leaking as well because of rubber seals. The contents of a capacitor is corrosive. It's not Windex. So it's kind of also that nuclear argument. It's, I know, I'm sort of pro alternative energies and whatever, but what happens to the nuclear waste? That is so bad, it has to be buried in the desert somewhere, but it goes in a metal container with a seal on it. Those seals are rated to 100 years. These capacitors, I mean, it's quite a metaphor really. A little tiny capacitor, you see how destructive corrosive electrolyte is. You can't store this stuff forever. So it goes through the seals, and I've also said it also happens just to crap parts. So, you know, you'll have examples where they'll talk about bad caps. Oh, this was the capacitor plague, this was a bad era of capacitors, but it's also 40 years. This is a gentleman that swore to me the caps were fine, and it's not bulging. It's not necessarily leaking, but what's underneath? So this is just more examples about why they fail. So this power supply is just underrated. It's just pushed too hard from factory. It'll last a year, sure, but it's worked too hard, and you get this sticky stuff. And you can see even these little holes, they start to physically pool with electrolyte. So again, that's an example, using your senses, looking at stuff, what's going on here. And so saying, look, are we doomed? Well, only sort of. You can still order capacitors, but it's possible every other part in your device isn't off the shelf. I get people that tell me, I'll give you a service manual. And I say, yeah, but a service manual is not a Jeremy do this instruction. It's a you figure it out statement. I have to learn that schematic, I have to learn what parts go in there, and I have to get them. So could we preserve the parts that are there by not blowing them up in the first place with all these leaky caps going on? Yes, that's why we're having this conversation. Don't forget, things are highly serviceable, okay? So the older the stuff, the less modernized it is as far as using adhesive seals, having lots of integrated chips that can't be ordered or replaced. It's not a dirty word to try and service these older power supplies. I actually think it's worse putting Pico PSUs in or buying $70, $80, $100, $120, $130 replacement power supplies. I think we could be also servicing this older stuff, because that's what I want, is to keep things going. And that's what everybody wants to hear as well. Just a couple more examples. This was an open circuit capacitor, and the thing is turned on and then future damage is done. You're starting to get the idea. Now, this is a little bit more technical, but it's an absolutely marvellous statement. So it's got nothing to do with me. I was taught by Hugo, and this is the quote. You're all humouring me, so I will talk you through it. The leaked electrolyte gets through the porous coating on the PCB, so your circuit board, and creates conductive pathways between the tracks. So we'll come back to that. This throws everything off, including voltage references and feedback circuits, which is what a power supply is. It's feeding back all the time what voltage is running. So it's a nightmare to the extent that normal fault-finding techniques fall on their heads. The reason that these conductive pathways effectively create a new schematic. I came up with the term invisible schematic, but he says new, which is quite true. So again, I'm giving you this example to say, look, if you are fault-finding something, you've got your multimeter out, you're trying to check what voltages should be here, how much current should be flowing through this. It's all a waste of your time if there's leaked caps, because nothing is working. So it's really important that we sort of come back to this notion of, do I have an invisible schematic? Because otherwise your job is too hard. He talks about using water, H2O being a polar solvent, 20 minutes, minimum, starts to leach the conductive compounds out of the surface. And then he talks about washing the board as well. So there are some products you can buy, which we'll get into a little bit further. It's just to kind of show you, on a vintage computer, these pathways exist, and we can do something about it. So ultrasonic cleaners, they're very expensive. They're quite cool. They're good on YouTube because stuff just fizzes off them. But we need to put a solvent in there first to sort of actually melt it off. And also a problem I've found with ultrasonic cleaning is that sticker residue vibrates at the same frequency. So I've pulled boards out and there's the little serial number sticker on the side, or there was some kind of other goo on there, and it's just vibrated across the whole board. So it doesn't replace physical scrubbing. If you're looking at getting some of your stuff out of storage, cleaning it up, all you need is a toothbrush, essentially, or a nylon brush. You don't need to go to the ultrasonic level. This was just a fun with flags moment. I've just started to put stuff in my ultrasonic cleaner and see what happened. It's an amazing kind of tool to clean a keyboard. Keyboards are gross and filthy, and they get all kinds of stuff. It absolutely just works. So you can put a keyboard in there and it still works afterwards. The drying process is important. Okay, so as all good things that need application in life, it comes with an applicator. It's a cream that's like shaving foam. This is a Macintosh SE board. Why would you wash it? There's no sort of surface mount caps on there, but there is a lot of dust. And what does dust do over time? It attracts moisture, which then leads to corrosion, but also creates another invisible schematic. So even dusty stuff has to be cleaned. That was $20. And I've gone through a bottle a year. So it does last. And who doesn't love results? It comes out shiny, sparkly. Okay, it really, really does work.
So what do? Jeremy, do you just spray it and then spread it over the water? Then...
Yep, you let it sit for about 10 minutes and give it a good rinse. If it's summer, you can leave some stuff outside to dry. I thought that was kind of me hijacking the backyard.
Jeremy, just a question.
Yeah.
With your ultrasonic cleaner, what solvent do you use?
Palm olive. Yeah. Yes, Nick.
Jeremy, so we discussed this on Thursday, but I'll ask
Sure.
a question with the audience. The 8-bit guy suggested putting it in your dishwasher.
Yes. Well, okay. The first thing I said to Neil is that you're rinsing your own food, plates and stuff in your dishwasher. So if electrolyte is this corrosive, I don't know, is it sort of still hanging around? It's not necessary, and it also doesn't touch. So we need to sort of scrub around and visualize our boards. If you put them in the machine, I kind of think it's a bit of heat stress too. It's say a 50-minute cycle. That it's just not necessary. Now, I'm saying we're not doomed, but also just sort of can't bring things back always from the dead. So when you're having a look, start to pick your battles. If you're seeing this much green, this corrosion has come in through that side and come out the other. It's come out the other side through the other side. You know what I mean? So if you're getting corrosion tracked through, you can wash it off. You can ultrasonic it. You can safe wash it. You can electrolube it. You can do whatever you want. If something has gone through something, it's dead. Or it'll die next year. This is an example of rust, though. Rust is fine. You can clean that off. And that's another best $20 I've spent is a Dremel Micro brass brush. It just melts the rust off. It's so soft you could put it on your body and you wouldn't even feel it, okay? But it gets the rust off. This is a little bit of a leap in sort of the theme, but it's a really common term online, dim bulbing, dim bulb. Anybody heard of dim bulbs? There's one here. So a dim bulb is how you turn on something seriously old. If you find a lovely little Astor 50s television on Facebook Marketplace, do you turn it on? Yes, life is for living, but can you do it a bit better? Yes. You can put a light bulb in there and it glows. So the idea is if a component is immediately short in your vintage something, very seriously vintage, the light bulb just glows and it shows you there's a problem. And it stops that excessive current going through the device. The light bulb lights up by absorbing the excess current. So even something like a hard drive, I had an Atari ST hard drive, a little 40 meg thing, huge hard drive. It drew, I think, 8 amps of current. That's enough to run an oven. You could, bake your pizza in that kind of level of energy, okay? That's because the motor was stuck. It was trying to spin up and spin up and spin up, and then it kind of burnt itself out. But I had a bulb on there, and it lit up like a Christmas tree. So you'd be surprised sort of how effective using a light bulb is. If you're a bit of a hoarder, you might have some incandescent bulbs in the cupboard, but ask around, get some light bulbs. They're actually a much more handy thing. I'm talking about incandescent, the old style, tungsten. So by slowly letting something turn on, one could say that is an act of reforming. So things are just a bit better when the electrons flow more smoothly opposed to whack over time. The fuses in things can be overrated, so they don't blow. There's problems. Fuses don't always blow, and they're also usually really at the front end of the circuit, so it's like if there's a very serious surge or a short, the fuse will blow, but if there's something further down the line, it's not fused. So the light bulb is very important. You might hear the term variac as well, but I tend not to use them because they're another sort of conversation, but I'm pro them. But now, this is the most ghetto example, by the way. This is ghetto. So what I've got is a light bulb with some alligator clips, with the fuse taken out, and then this clips in place of the fuse terminal, and the light bulb is my fuse. So it doesn't take, you don't have to make, I do have one obviously, but a PowerPoint. You can build a light bulb into the PowerPoint and run it that way, but if you want to get started, it's not that hard. Now, this is talking about, okay, longevity. So how long do we need to turn our old stuff on? It's finally been studied. It was actually sponsored by Nichicon of Japan, 12 months. So if we have something very old, do we need to dim bulb it to reform it? If you do it every year, that's the sweet spot in healing a capacitor, to sort of get its self-healing thing. So keep that in mind. With my vintage computers that are on display or even on shelving, I've got just a long IEC cable, a long power cable. That's just what tipped it over the edge. I had stuff sitting there I hadn't turned on for years. It was because I didn't have any power. It was just too much effort. I just got a long cable and I just plug it in and I turn something on. That's a good idea. Just make it easy for yourself. So we're talking about capacitors, and of course, if one wants to throw money at a problem, you could buy a meter. And you could buy an ESR meter, which is a wonderful way to test capacitors. But that was all just has turned out to be the biggest crap I've ever heard. I'm sorry. It's not that it's bullshit or a scam. It's just that the ESR meter can't tell you that the capacitor is bad. It's not enough. It's a battery-operated device. 30 years ago, you could buy a proper capacitor tester that put the capacitor under test. It actually put a load on it. Think about it. If you're using a battery-operated meter, how much current is it giving that capacitor? 10 milliamps. I mean, that's not even going to tickle your tongue. So this sort of conversation is looking at, I'm telling you to replace capacitors ultimately. We're going to prioritize that. But I have had so many examples now. There might have been some photos where I've used the capacitor tester and it's come back as a good cap. I've then had something sent to me. This is many sample size, I promise. The caps were fine. I've tested them as well, but it was still ultimately the goddamn capacitor that had failed. So I couldn't even test for it. And I could have saved so much time, which is why I'm telling you this, if I had have just recapped it in the first place, because the meter was wrong. Oh, okay, so the one I bought puts 20 milliamps underneath it. So talking about temperature and big caps, these are the last thing that anyone would ever bother putting into a power supply. They last forever, don't they? They're filter capacitors, they're huge, they're reliable, but they also can short out. They're also not vented properly too, so they're a bit of a safety problem. That's after I had the wherewithal, after I got the fire extinguisher and cleared an exit and put my oxygen mask on. I got the temp probe. This was, and then got the camera. This was up to 110. I heard it, so I told you before, use your senses. I heard something. So the filter capacitor was venting and boiling to death while this happened. It wasn't necessarily the fault of this, but it had a reefer capacitor in there. Who knows what a reefer capacitor is? Yeah, you'll never forget the smell of toffee. It's not even fun, the smell. It's an awful toffee smell when they go off. So the reefer capacitors are in lots of things. When they short... a reefer capacitor is designed to fail open. So it's supposed to be like a fuse of sorts. They fail short, which means that the electricity they were supposed to hold off ends up flowing through and it doesn't stop. It just goes higher and higher. As it physically burns, capacitor, these reefers, they go... As they burn, they draw more current. And they keep drawing more current because the fire is still happening. Do you know what I mean? It keeps going. So this Macintosh 2 power supply, the reefer failed on it. It kept drawing current, which then shorted a certain triac here, which then sent 385 volts through that capacitor. But you wouldn't know any of that. So again, if we just go back to the start and we open up our power supply and we see a reefer capacitor in there, if we replace that, or you can even cut them out sometimes, we then don't have to replace a gate-sensitive triac that was made for 2 years. We then don't have to replace these at $7 each. We then don't have to replace this transistor here, blah, 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 blah. It can all be done, but we're trying to avoid this sort of very serious blowing up of things, ultimately. So this kind of refers to some online vibes I've heard about. It depends what YouTubers you watch, but is recapping the right thing to do? It's maybe a bit of a dirty word, and it's just because some others have perhaps ruined it for others in the sense they've done a bad job, or they've ruined it for themselves, and then sort of put it online and said, why isn't this working? It's just the ultimate eye roll, and you see the worst soldering, or we're talking about very bad jobs here, or they've put shit back in. Why did you recap the whole thing? Of course it's not working if you haven't sort of done it right. So it's become a bit of a problem. I'm seeing more commentary than ever that recapping is a bad idea. Why would you? It's got to be an IC. These are the comments typically coming from technicians that worked in the 80s and the 90s when capacitors weren't a problem for them as well. So of course, why would you suspect a capacitor? I guarantee you that's got to be done. So it's about the approach. We're not talking about spraying and praying, recapping everything. We're looking at the circuit. We're looking at, visually, this is all visually stuff you can do. We're looking at the circuit. Are there dry joints? Is there leaked electrolyte? Are things visually a problem? Before we recap everything, we address all the obvious stuff first, right? A lot of people talk to me about why, every single person actually, even I think just this morning, why don't I have a YouTube channel? That's another sort of question. But these are two people that I adore. I think they're fantastic. They've got wonderful YouTube channels. But it's sort of, the devil's a bit in the detail. So a savant, a guy that's a savant, okay, exceptional knowledge. He knows everything about valve-based televisions and radios. He'll spend an entire month crapping on about why we're not recapping something. This is a bad idea. This is a waste of time, blah, blah, blah. Whoops, I've knocked something. And the next month, he recaps the whole television because there was one bad capacitor that blew 4 transistors that he had to order from Japan. If only he had have replaced the capacitor that was shorted the whole time. So it's when you start to get the follow-up, like, oh yeah, recapping's bad. We can't do it. And then the next month, they're recapping. Mr. Carlson's lab, he's a Canadian, a wonderful photo. I'll just skip forward and show you the photo and then come back to this. These are, I could have this space. Do you know how deep that desk is to fit all of those things on there? This is an ultimate room for a collector dude. And I thought this was quite a marvelous visual too. I kind of had this dream where this stuff was falling in on him and he would die happy. Do you know what I mean? So he is an expert. I could, go my whole life and not be as smart as him. So he does a whole talk. He talks about AC current limiting, which was the dim bulb and the variac. So he dim bulbed, he variaced. He talked about the importance of protecting the gear. It's a 60-year-old radio with all of the protection in place, but it has wax capacitors. They're fine. They test fine. They don't test as a problem, but as they heat up, it's a different story. So they start to short, which causes the valves to red plate, so it's glowing a volcanic red. We're talking 400 plus degrees. That's not exactly safe. And it draws too much current on the transformer, which then starts to boil. The windings literally vibrate and boil, and then it goes open circuit. So if you had to just replace some capacitors, the whole thing could have been saved. And he was sort of following the recaps the problem vibe again. I can't get you a transformer from 1960. I can't get you any kind of spares that are that exotic, but I can get you a replacement wax capacitor of DigiKey. It could have been done. And the whole radio literally melted. So, so if you're getting into capacitors, these are some things to remember. Ripple current. Higher is typically better when we're buying our stock. Do we buy something from JCar? Well, maybe. If you want it to last a bit longer and not do the job twice, you might get something off of DigiKey or somewhere reputable like Mauser, and you might get a capacitor that could be technically better than what was there to start with. But we would use our sensors as well. If that capacitor has failed in that particular spot, then you would know you could upgrade it to a higher capacity or one with better ripple current, because what the manufacturer put in there wasn't good enough. Do we understand what I'm saying there? So the question is, if there's a 200 microfarad capacitor at 16 volts there, the OCD in someone, or the perfectionist in someone, or the fear, the ego in someone will say, I'll have to put a 220/16 back. But it failed. So why would you put the same value back? You keep the microfarads, sure, but go up in voltage or go up in ripple current, because it was clearly a part of the circuit that was drawing too hard. Some capacitors are actually really hard to replace as well. So it's a bit of research. This makes sense to probably one person in Australia, but there's a certain rebranding of what capacitors can do. In the 80s, they had things called high-frequency capacitors, HF. But you can't buy HF capacitors anymore. Turns out the terminology has changed. And so when you start to read some data sheets, you'll find that. We've talked about IPA. I hear all my favourite YouTubers, IPA, got to use IPA, spray. But it's just not very strong as well. It's also quite expensive. So you can use some metho, all right? Get some metho, clean up your boards with that, okay? Don't sniff it too hard, lovey. Want to keep your vision for one day. Oscilloscopes, they're great. They're great. But they're shit for trouble and fault finding unless they're digital storage. I've wasted so much time trying to use old cool oscilloscopes and got nowhere, but got somewhere really quickly with a $120 AliExpress special. So digital storage if you're getting into old scopes. And just telling yourself, remember, component testing is bloody hard, especially if you don't have a spare board to compare it against. So if anybody wants to get into this, repairing, restoring of their old things, have something you can do a sanity check against. Have two, so you've got the spares. We don't want to go down too many rabbit holes. If you're watching YouTube videos in your home alone, how do I know this? Ask me. You can't ask questions, and you don't have a spare to compare it against. So you have to sort of... Yeah. Well, you get creative with your storage. I mean, I've got stuff behind cupboards, under the house. There might be something still stored in my boot that I can't quite unload just yet.
Some capacitors are not heat rated enough.
Yeah.
They've been designed too close to something that gets hot and they get cooked.
You're talking about heat?
Yeah, so the capacitor over time gets cooked by something in the power supply that gets hot.
Yeah.
So if you're replacing it, you'd go for a higher temperature rated one.
Not always. And do you know why? Higher temp capacitors have lower ripple current tolerance. They have lower ripple tolerance. So look at the circuit, maybe feel it. If you can touch it and it's not that hot, an 85-degree cap is probably fine. We just want to be putting back a better quality capacitor. I've just learnt that mistake is all. Having said that, a 105-degree cap is generally better than an 85. So absolutely relevant. Oh, no, this is important. So document. It makes life so much easier. Do you know the website iFixit? Why did that website exist? Who knows the story of that? It's as simple as someone being tired. They took apart their iBook at 10 o'clock at night, woke up the next morning and couldn't remember where a damn screw went, and thought, oh, this must be a problem that other people have. There's a chance if you're going to be doing some recapping, some restoring work, you're going to be tired. You're going to be doing it after work. And you're also going to be testing things with your multimeter. I cannot tell you how important it is to write things down. So this is a transistor table that I use. There's my 808. Yeah, if you know, you know. So I write down Q614. What was my red on base? BCE was on the circuit board. My base, my collector, emitter. Where did I put my red probe and where did I put my black probe? What did the meter say? 0656, it gets written there. Then I swapped the leads. What was the reading? And this is great because you fill this row out, you then get your second board, your parts board, that you're not supposed to have because there's no space, and then you check the same one. Did I get the same results? It also means that if you're doing this professionally like I am, you get some documentation to show someone, this is what I did, this is how I found the fault. It also means the next generation goes, Q614 was replaced because... please always think about, am I documenting? Am I putting a sticker on the back of something? Yes, you are. What was done? What have I fixed? What have I replaced? If anybody here is into CRT televisions, raise your hand. It's a safe space. Yeah. Yeah. So my nickname growing up was Mike TV. I had to tell myself that because I forgot, I lost my path. I never ever actually owned an LCD TV, ever. I held out until OLED. But I've been repairing them as just something that is my true calling in life. No, it's not. My calling is to be here with you. My calling is to be an instrument of love, to help you rise to the level that you could be as a repairer, as a hobby enthusiast. But we have our things we fixate on. And I love CRTs. I also love not getting shocked. I also love it. I also like money and I like business. So I've had 3 customers now. So I'm talking myself out of a job that didn't put these back on properly. And what does that sit on? It sits on the back of a CRT, which has got a coating on it called a DAG, which is a conductive compound. So they light up like Christmas trees as well. If you're ever putting a CRT back together, you're going to check once for me. You're going to check twice. You're going to get some pliers and just pull it up and have a look. Are both the scissors or both the prongs sitting in there firmly? Because what happens if they're not? Your flyback transformer is open circuit. Can I get you a flyback from 40 years ago? Maybe. But I have to ask really nicely, and I have to ask every single person in this room at this fair, who's got a flyback for a 1984 Panasonic Dymatron? No one. So, yeah.
Taking the anode cap off can be quite dangerous. Like, it's an anode, so you take the voltage and shock.
Yeah.
So you really have to know what you're doing, because normally you stick a screwdriver under that and close it.
Yeah. So that's a great point, but I might make you feel bad. Do you feel self-conscious about that question?
Was that a stupid question?
No, it's a fantastic thing, but it might be one little thing that'll shock you in that even more. What is Earth? It's a common point in your circuit. It's the common point that everything in DC is tied to. So if you take a screwdriver and clip it onto the chassis, where does that charge go? It doesn't go through you because you're using a screwdriver. Where does that excessive kilovolt go? It goes through the ground plane of everything in your monitor or your circuit. The reason we're having this conversation is YouTubers, because they will show you their crappy bit of wire on their screwdriver with a clip lead onto the chassis. Do you know what is missing there? It's called a bleeder resistor. It just needs a mega ohm resistor from the screwdriver through the resistor and then to the wire, so that that current, that voltage can be dampened by something before it goes to ground. So ask questions. Now, 2 quotes to end on. Check your assumptions. Check your assumptions. What does that mean? Who wants to raise their hand with an example of what that might mean? Check your assumptions. Check how swishy somebody is. You're checking things with your gut feeling all the time. Go ahead.
You're assuming the power supply for your Amiga is going to be working perfectly.
Yep.
You're taking a really big risk of that.
That's right. Because the power supply is the first stage of your computer. So it's the most important. It's feeding everything through. Having said that, an Amiga power supply is pretty serviceable. Have you cracked one open? Yeah. Yeah, some of them are terrible. They're a bit cost reduced and a bit cheap, but some of them are actually still pretty reliable. I think it's the Commodore one that's got the most fear around it, doesn't it? For valid reasons. So checking your assumptions to me means that I think this capacitor is bad, so therefore it's the problem. I think that if I replace this will work. I am constantly checking, am I assuming that this will work, or am I really going to go down a rabbit hole? So if you're doing something, always say to yourself, I assume finish the sentence, and just check it. Ask someone. I assume if I replace this will fix it. Maybe it won't. It's just trying to save you time. The fantastic thing to tell yourself as a technician, as a repairer, as a hobbyist, is show me where you've been or where I've been on the circuit in the repair, and I'll show you where the fault is. Does that sink in at all? Does that make sense? Show me where you've been and I'll show you where the fault is. Did you put a capacitor in backwards? So you zoom in on what you touched. Did you solder it as well as you thought? Did you check your work under magnification? Did you put enough flux down? Maybe the solder joint's bad. Things you do are where you go back and check first, because that's where the fault typically is. It's proven itself to me 1,000 times. We're all doing this, like I was saying, we're tired, we make mistakes, we get excited, we turn stuff on. So show me where you've been and I'll show you the fault. That's my mantra to myself. I check my work. Check yours too. That's the end of the thing. So I started 11:15. I'm off at basically now. I can talk for days. Any questions? Pat?
How'd you get your start in CRT repair, Jeremy?
The answer is survival of the fittest, and I'm not even that fit. I'm just emaciated. Survival of the fittest means no one else was repairing them. And I just couldn't accept having stuff that didn't turn on. I thought it was a bit of a shame, really, that I needed to live in a world where I had to say, well, this is a photo of this line on my CRT, what do I do about it? Because every other person that replies on Facebook just goes, ugh, have you checked the capacitors? Have you checked for dry joints? I just had to get stuck in there and rely on myself a little bit. And it's turned out to be quite interesting. That's how I got started. I got beautiful CRTs that all died. They all died. And I got to tell you, it's just dry joints, a lot of them. Okay, here's something. Yes, mate.
In your experience, how often do you find flybacks actually gone in CRT?
1 in 100. Yep, I've had one, and it's Mark Sharrock, who's here today with his lovely PCX 6800. That was the only customer I've ever had with a bad flyback.
All the recapping's done. 1 in 100 flyback.
Yeah. Depends how old it is. If it's from the 50s and 60s, different story.
The 80s.
Yeah.
Commodore stuff, Apple stuff.
Yeah, so the Commodore stuff is controversial in the sense that there are 2 capacitors that feed the flyback. And they're not electrolytic. They are film capacitors. So who thinks that they're a problem? No one. That's what eats the flybacks. And I got the receipts as well. I can show you. So 2 film capacitors next to the flyback. You change those, it'll stop eating them. I mean, this actually goes back to Methuselah. I've got forum posts from 1996 of Commodore 1084 monitors with bad flybacks, and they've put another flyback in and they've died. Why? So that's the answer. Time to wrap up? All right. It was my pleasure. I can't believe someone listened to me for this long. Thank you. I'm here for you and only you, my fans. Joan Crawford.
This was recorded at the Canberra Vintage Computer Exhibition 2004. To find out more, check out the links in the description.